Hello, today we will look at how the lines of the spectrum, the emission spectrum of the hydrogen atom, are arranged. In the previous lesson, we talked about the fact that the spectrum of hydrogen, and which is the very first chemical element, exists in two forms. There is an absorption spectrum, there is an emission spectrum. Let's look at the emission spectrum in more detail. Why is this so important? This is because the emission spectrum makes it possible to accurately identify a chemical element, in this case hydrogen. Now let's explain where the lines that you can see in this case come from. Red, green, blue, and purple. Let's see what it looks like if we analyze it, taking into account the levels at which the electrons are located and from which level to which in motion, in this case, the formation of each of these lines occurs. So let's look at this in our chart. The graph is built in ascending order of energy. The N that you can see are the numbers of the energy levels. So the line that you can see first, the red line, it corresponds to the transition from the second energy level, if the hydrogen atom is in an excited state, to the first. This line corresponds to the transition that you see of the red line in the emission spectrum. Then the line, which is green, corresponds to the transition from the fourth energy level to the first. This is the line that you can see here. If we talk about the blue line, it turns out that this is the transition from the fifth level to the first level. And accordingly, if the movement is from the sixth to the first level, this corresponds to the violet line of this hydrogen emission spectrum. And once again, when we talk about the emission spectrum, in this case, we should understand that the movement from the upper energy levels towards the lower energy levels, this transition, well, here you can see the core. It is always accompanied by the release of photons. Recall that photons are quanta of light, and photons in this case will be released. In this case, the photon energy can be calculated as the energy difference of the upper level minus the lower level. And once again, let's clarify that when we talk about the visible spectrum, it turns out that this corresponds to transitions from different energy levels towards lower energy levels. At the same time, the larger this transition is, it means that it corresponds to the line of the visible violet spectrum. The smaller the transition, this will correspond to the transition of the lines of light, resulting in red, which we can observe in the visible spectrum. Thus, the hydrogen atom, its lines that we see here, they are deciphered as follows. That is, these are transitions from the upper energy levels towards the first energy level. But let's clarify once again. In this case, the hydrogen atom is in an excited state. That is, it is given a certain energy so that it is at the upper levels because hydrogen has only one electron. Therefore, in order to make it rise up, it is necessary to apply naturally a certain energy, but already when descending, it will accompany. This transition is defined by the emission spectrum lines, which you can see in this case when we observe the emission spectrum of the hydrogen atom. In exactly the same way, we can look at other spectra of other elements, in particular sodium, potassium, iron, where there will be corresponding other transitions corresponding to these color lines, which we can observe only for other chemical elements. So, what is the emission spectrum? I hope now you have become clear, and this will allow us to henceforth learn to determine the quantum numbers that describe the movement of electrons in the atom. Now we're ready for that, to understand how electrons move in each of the atoms of the chemical elements. Goodbye.